Okay, I can now draw polygons on my infinity checkerboard. I'm going to show you what it does here. When the program runs, we have a spinning pentagon here, and we've got Twilight Sparkle. I can still move Twilight Sparkle, and I can still move I can move the checkerboard in all of the usual directions, which is so neat. And I can make the squares smaller or bigger, and things look really weird as I change that square size. Oh man, that looks freaky. I don't know if you can even see that. Whoa, it looks so different. Okay, yeah, it's just, whoa. Okay, anyway, you get the idea. We have a spinning polygon here. Now, how does this spinning polygon work? Well, I'm about to show you the source code here. So I'm in my folder here. So first, I'm going to show you main.c. So I have all of the same code from my previous videos where I show up my source code, but now I have some variables defining a polygon. Now they're not declared in this file, they're declared in a different file. I'll have to show you that file as well. So let's change polygon size here to 3. They are initialized here before the game loop. Okay, I'm going to change the size to 3, and then I'm going to change the polygon color. I'm just going to change the polygon color to white, and I'm going to go down here and show you. Okay, somewhere around here. Oh man, yeah, I am lost in my sea of code here. Okay, so here is where things get interesting. You see this? Now this is, okay, so this is where all the surfaces are blitted. All the images are copied onto each other. So first, we're copying the region of the checkerboard that's currently going to be shown from surface 1, which is where it comes from, to surface 2. Then we're setting the surface pointer named surface to surface 2. And then I'm calling my polygon surface function, which puts a regular polygon onto a surface based on the variables above that I showed you. Now, polygon radians here, this is where it's incremented. I'm going to change this from 0.1 to 0.2. And then then it blits the surface. It copies from surface 2 to surface 0. Okay, so that's cool. So now I'm going to write this file, and then I'm going to make it. I'm going to recompile the program and run it. And now what do we have here? Now we have a triangle here. We have slightly different colors going on here. But yeah, we have a triangle, but everything else is still pretty much the same. And oh, and the triangle is moving faster. Notice that it's moving faster? That's because radians is the variable that I set, which is the current rotation of the polygon. Okay, so that's super nice. I mean, it looks very pretty when it does stuff like this. Yeah, that's just so cool. But the rabbit hole goes even deeper. It goes way beyond. Whoa. Okay, now that's a glitch. That is not even supposed to happen. I don't even know what's happening there. Well, yeah, when I make the squares too big, I get this weird glitch thing going on. Oh, okay, that's cool. I'm going to exit the program, and then I'm going to make another change. Now, notice here, this copies the player onto surface 0, which is the screen. But I'm going to do something. I am going to, I'm going to delete this line, and then I'm going to put this line to just before we draw the polygon. So I'm going to, I messed up. Okay, yeah, I really am not very efficient at this yet. I'm trying to, okay, so, we are setting the, you know what, I'm going to move it up one more line. Okay, so here we've copied surface 1 to surface 2, then we copy the player onto surface 2. We're going to change this from surface 0 to surface 2. So we're copying the player onto surface 2, and that now the player is going to be copied before the polygon is drawn. And you're going to see what's going on here. So I'm going to recompile and run this just to show you a cool effect. Now, is this cool or what? Note, you see the I have the triangle set to do an XOR effect. So it's basically inverting the colors, because the polygon color is technically white, but it's inverting the colors behind it, because the checkerboard's drawn, then Twilight Sparkle is drawn, but then the polygon is drawn, but it's an XOR operation. So basically we have this just weird effect. So Twilight Sparkle's colors are going to invert every single time that triangle passes over here. And just for the sake of making it look ultra cool, I'm going to show you my personal preference. The last thing I'm going to show you in this file is simply that I am going to, we're going to set these colors here back to, yeah, we're going to set that to 0, and we're going to set that to 255, and then we're going to save it. And then we're going to run this one more time. Okay, now that's actually very weird. Why is I'm actually not too sure about this. This is weird. I'm not entirely sure why it's inverting the colors in the manner that it's doing. I may need to check something, because something's not right. That's just not right at all. Okay. Well, wait. Oh, I see. There's one F missing from the polygon color. It wasn't fully white. Okay, that's what was wrong. Yeah, okay. So yeah, now I want to show you. Now everything should be the way I like it. Okay, that's right. Now we have the we have everything black and white except for Twilight Sparkle herself, who inverts colors every time the triangle passes over her. Okay, so that's nice, and the checkerboard can still move, and the squares can still be made smaller. Whoa. Whoa, that's cool. Yep, and they can be made bigger. Whoa. Okay, yeah, I am getting a little bit carried away here. Whoa. Okay, yeah, that's just weird. I have broken my program. That's just strange. Okay, anyway, enough of that. So now I've shown you everything that I need to show you from within this file. So I'm going to quit this file, and then we're going to vim my other file, which has a slightly longer name, but it's very descriptive. SDL Bbm Polygon.h. Okay, now this is the file that has all of the various functions associated with this polygon. Okay, so here we have, I have a comment that I copied it from my original BBM library. So we're including the math header, part of the C Standard library, and then we're defining a huge array size. We're defining a static array that's compiled into the program, because I use a temporary array as part of this. And then these are all the default attributes of the polygon, you know, and they can always be changed later from anywhere else in the program. So a polygon has a number of sides. We have arrays of the x and y coordinates. We have its center x and y position, its radius, which is its size basically, and then radians is set to 0, the current rotation of it, and then the color finally. And then, yeah, it's crazy. So here we define pi, and then we have sign of it, which tells if a number is negative or not, and then we have the rounding function. And this is important for rounding floating point to integers, because it's all integer math of the line drawing algorithm, even though it's using floating point for the original points themselves. Okay, this is the function get polygon points, probably the most important function here, because this uses the sine and cosine functions to actually get the x and y coordinates of every single corner of a regular polygon. And it uses tons of variables, it rounds them to integers, and then it stores them into the arrays here, which is great. So then we have Bbm Fill. This is simply used, I copied this directly with no modifications for my BBM library because it just simply fills an array of pixels with a color. So I use it to fill an array of pixels with black, is precisely what I did. Later on you'll see. And this is the line drawing algorithm that I copy pasted from somewhere. And yeah, it's complicated. Even I don't understand how it works, but it's the Bresenham line drawing algorithm. I just needed a line drawing algorithm because SDL, unfortunately, although it can draw lines, you have to create an SDL renderer. It doesn't let you draw a line directly onto an SDL surface, which is really, really stupid in my opinion, because it means I have to spend a whole bunch more code with a renderer when I just want to draw a line. SDL is horrible if you like to draw lines, but it's good in other ways. And then this is named BBM Polygon. Technically, it needs a better name, but it works for right now. This is where it calls the line algorithm to repeatedly draw white lines. You'll notice it's drawing lines of white pixels. They're currently white, and that's fine because they're changed later. So then this is a function that draws a polygon to the temp array. So that global array that I defined earlier that has a large size, this is where it first fills it with black, and then it calls the other function that draws the white lines. Okay, then it gets even crazier. This is a function that is used to scan fill. So it scans each line, and then it finds the leftmost white pixel and the rightmost white pixel on that line, and then fills the space between. So that's how I fill in my polygons. It's a really quick hack that I made a long time ago, and quite honestly, it works. It might be slower than, there might be a better method out there, but it actually worked, and I wrote all that code of the scan fill function, so I'm proud of it. Okay, now the hardest part. That's the comment I put in there. Okay, so as you see, we're defining some variables, and then it gets the width from the surface structure because it's actually going to copy from the temporary array of pixels onto an SDL surface. That's what it does. So it gets the width, and then it locks the surface so we can access the pixels. Then it uses a 32-bit integer pointer, and sets it equal to the surface pixels pointer. So we're going to be directly accessing the pixels, which are 32-bit integers. And I even had to use a typecast. That's the way you have to do things. Actually, I want to make one small change here. Wait. Okay, yeah. I want to. Yeah. This is very weird. I don't understand everything about this Vim thing. Okay, anyway, I want to focus on the program here. So here we have, it goes through every single pixel in the source image, which is the polygon array 0. First it draws the polygon to the temporary array, then it does the scan fill operation, and then it cycles through every single pixel, which is a big operation. And then here's where it gets interesting. So notice it says if polygon array 0 of that element, it doesn't say if it equals this or if it's greater than that. It doesn't do that. It's simply if that. And the reason for that is because anything that is 0 in C evaluates to false, and anything that is not 0 evaluates to true. So the point is, if it's not 0, in other words, if it's any color other than black, which is 0, then it's going to copy from the, at that same spot, it's going to copy it to the surface pixel pointer, whatever the polygon color is. Except in this case, no, it doesn't actually copy the color, it XORs the color. Now I can change that. So let's say that I do want it to actually just copy the color. In that case, I just saved it. Now let's try recompiling the program and seeing what it does. You see now it actually just copies the it copies the color, which happens to be white in this case. And that's nice, we have a white triangle, but that's not as exciting as before. You know what I mean? So what we're going to do is we're going to undo that, and then we're going to write the file, and then we're just going to make it go back to the way it was. Personally, I like the way this looks. I like the way it inverts the colors. And even though I am recording a video, it's still reasonably fast. You have to admit, it is still reasonably fast. If I had a faster computer, or if Windows 10 wasn't such a memory and CPU hog, it probably would be faster. Windows 10 is really sad, because when I was running that Linux distro from CD, it was 10 times faster than running in Windows 10. But since that Linux distribution doesn't include the drivers for my microphone, you can't hear me if I record videos on that system, which is very, very sad. But anyway, I hope you have enjoyed this amazing program I wrote, and I hope somebody understood something about my polygon routine. I have worked on my polygon routine for a really long time. Anyway, I've been working on this code for like 8 hours today, so I think I better get off the computer, but after I back up all my files and upload this video. Hope you guys have enjoyed, whoever is listening to me. Okay, goodbye.